In these notes, we're going to do some practice and we're going to also look at the average value function and practice using the average value function. Now, when we talk about average value function, the formula is the area under the curve of f of x. So we're trying to find the average value of f of x. We find the area under the f of x and we divide it by the width, and that will give us the average value of f of x. So it looks like this in the formula. It's going to be 1 over b minus a. So b minus a represents the interval width. A and b represent the end bounds of the integral, the area that we're doing, and f of x, we're finding the area under f of x. And this formula gives me the average value or the average height of the f of x function. So looking at the sine x graph, if I think of what the sine x graph looks like between 0 and pi over 3, I'm going to sketch in my sine x. So this is sine x, that's to pi, okay. Pi over 2 is going to be at the max, and pi over 3 may be somewhere about here. Okay, so that's, I want to find out the average height of this section of graph. Now, the average height of that, what we do to find average height is this. We take this area, okay, that's going to be the integral part of that formula. Take the area under the curve, and then we kind of rearrange it into a rectangular area where the rectangular is maybe a little bit lower than that. Okay, so maybe right about here, that's going to be the average height. And we can tell if it's average height if this little bit in here matches the part that's out here. Okay, and that gives us then that line that I've just drawn in. This represents the average value or average height. And to do this, we use this formula. So I'm going to apply this formula here. So I'm going to find the average value of sine x in that interval is going to be 1 over the interval. So it's going to be pi over 3 minus 0. And then I'm going to integrate the area from 0 to pi over 3. Okay, squeeze that a little bit here. And this is going to be of the graph of sine x. That's going to give us the average height of sine x. So integrating sine x, okay, so first of all, I'm going to do this part. It's going to be pi over 3. The integral of sine x is going to be negative cosine x. And I'm going to find the area between 0 to pi over 3. Okay, just rearranging that fraction, the dividing by pi over 3, I'm going to multiply by the reciprocal. Cosine of cosine of pi over 3, the cosine value of pi over 3, or at 60 degrees, is going to be 1/2. So I get negative 1/2 minus negative, the cosine of 0 is going to be 1. So I'm going to end up with minus negative 1. Okay, so then the area part of this works out to be negative 1/2 plus 1 is going to be positive 1/2. That's the area. That's that kind of yellow area that I found. Okay, and I'm just going to color code that. This represents that yellow area that we found. But to find the average value, we multiply it by 3 over pi. So this works out to be 3 over 2 pi. Okay, so that represents the average height of the graph. Okay, or in other words, the average value. Okay, so we can do the same thing here. We have this 1 over x function. Okay, sketching a quick little picture here. 1 over x between 1 and 10. Okay, it's this function that's going to look like that. Okay, at 1 and 10. Okay, I've cut my scaling's a little bit off, but there's my graph. That's my area. I want to find the average height. What I'm going to do is use the formula. So average value, okay, looking back at the formula, it's going to be 1 over b minus a, 1 over 10 minus 1, and the area from 1 to 10 of 1 over x function. So this becomes 1 over 9. The integral is going to be log x, and then we're going to find the area from 1 to 10. Okay, so this portion here represents the area that I'm looking for. Okay, so that's going to be this area in here. Working out the rest of this, I get 1 over 9 log 10 minus log 1. Okay, this works out to be, and again, I'm just going to keep this consistent. That is the area. The average height, or the average value, is going to be log 10. Okay, so that's my area. The average value, or the average height, is going to be log 10. And we divide it by the width, which is 9. So log 10 over 9 represents the average height. Okay, so this is the same as 1 over 9 log 10, which works out to be log the ninth root of 10, and that's approximately equal to 0.26. Clean that up a bit. Approximately equal to 0.26. Okay, so that is the average height of that function. Kind of makes sense because that would be at 1 and 0.26. Yeah, that could represent the average height of that function.